In our second example, we have a ball that's at rest at the top of an incline. We're going to let that roll down. It'll be about halfway down in the second diagram. In the third diagram, we will assume that the spring brings the ball to rest. So the spring compresses, the ball comes to rest. So we need to choose our total amount of energy. So again, I usually choose 6 just because it's a nice even number and there's enough blocks that we can usually split it up pretty evenly. So in the first diagram, again, I'm going to ignore the charts down below. In the first diagram, the spring has 0 blocks of energy because it's not compressed, which means the ball must have all 6. Now, it's not moving, so all 6 we'll say are in EG, because if it's not yet moving, none of those blocks can be in kinetic. So of the 6 blocks total that we selected at the beginning, all 6 will be in the ball in the form of gravitational potential energy. We'll jump to the second diagram. Second diagram, that spring still has not been compressed, so it cannot have any energy. The ball still needs to therefore have a total of 6 because the whole system has to have 6. In this case, it's lower than it was before, so I just have to choose some number less than 6 for EG. I'll make it 4 here, which means that the kinetic must be 2, because as that ball rolls down the hill and loses height, it's going to pick up some velocity. In the third diagram, that ball is slammed into the spring. It is on the ground, so therefore it has no EG. It's not moving, so it has no EK, so the ball must have 0 total. And therefore, in order to make sure my total always equals 6, there must be 6 blocks of energy in that spring. All right, so in all 3 cases, I total up to 6. The energy is in different amounts in different objects, but I get a total of 6. Now I can slide down to my graphs down below. I can look at system number 1, which is the ball. I simply ignore the spring. So in diagram number 1, the ball has 6 blocks of EG, so I'm going to put 6 blocks. It has no EK, and the ball doesn't have elastic potential energy. So I'm going to go ahead, I'm going to cross out EEP for all 3 of these simply because the ball does not have EEP. We say the ball only has EG or EK. So because the system is the ball, we're never going to have any elastic potential energy. Only the spring would have that. In the second diagram, I can see now that from up top, I have 4 blocks of potential energy, and I have 2 blocks of kinetic and 0 elastic potential energy because I'm not considering any springs. In the final diagram, the ball is on the ground. It has 0. It's not moving. It has 0. So across the board, the ball itself has lost all its energy. Now I look from left to right at my graphs. A total of 6 blocks in the first diagram, 6 plus 0 plus 0. I have a total of 6 in the second diagram, 4 plus 2 plus 0. Total of 6 for both diagrams. Therefore, there's no work. If I look at the second to the third graph, though, 4 plus 2 plus 0 gives me a total of 6 for the second graph. I have 0 for the third graph, so therefore work must have occurred. What happened? Well, the spring took 6 blocks of energy from the ball. The spring is not part of our system, which in this case is just the ball. So something that is not the system, the ball, took energy away. Now we can go ahead and use the same numbers up top to analyze a different system. In this case, for the second scenario, the ball and the spring. So now I'm going to go ahead and I'm going to look at the ball first because that's the first thing in our system. I see it has 6 blocks of EG. It's not moving, so it has 0 blocks of EK. Now the second item in my system is the spring. So I'm going to look up top and see that in the first diagram it has 0 blocks. So I start with 6. I then slide to the second one. It looks like from the numbers up top it has 4 blocks of gravitational potential energy, 2 blocks of kinetic energy, and the spring has 0, so therefore no elastic potential energy. In the third diagram, we'll take a look up top. Again, the ball is on the ground, has no EG, it's not moving, no EK, but the spring has 6 blocks of elastic potential energy. Now, looking from left to right, 6 block total for the first diagram, or first graph, 6 blocks total for the second graph, no work occurs between them. 6 blocks in the second graph, 6 blocks in the third graph, no work occurs. The only energy that transferred in this situation was either within the ball, e.g. going to EK within the ball, or the ball gave its energy to the spring. Since the ball and the spring are both in our system, there's no other object that interfered with anything here. So since we only had a ball and a spring, everything was in the system, so you're not going to have any work.